Hey guys, welcome back to the channel. This is going to be video 3 in a series of videos kind of showing you guys how to create on-track videos that have multiple angles, good audio, as well as data overlay. In the first video we covered the hardware required to capture multiple angles as well as get some decent audio and the different pieces of software that we're going to use to put everything together. In the second video, we covered data loggers, and instead of covering all the different types of data loggers, I went over the reasons why I chose the Autosport Lab Racecapture series of data loggers. And in this video, we're going to kind of start getting into the nitty-gritty things that are involved with actually getting data from the car. Fortunately, the data logger in the WRX had a Wi-Fi issue. It still works, but I sent it back to Autosports Lab for some servicing. They're going to try to figure out what's going on with it. However, the Cayman has a data logger as well. So in the second video, I was talking about the Racecapture Pro, and this was actually the first car to get a data logger, and it actually has the Racecapture Pro. So it is actually mounted underneath my seat, and there's a wiring mess down there, and I prefer not to show you guys that. But I wanted to cover kind of the basics of getting CAN data from the car. So before we kind of go any further, I just want to say that we are covering CAN Bus, and we're not covering the OBD port. Unfortunately, I didn't have to learn how to play around with OBD at all for either of these cars. Everything is available on the CAN network that I was looking for. So if you are looking to do OBD data logging, you'll have to look elsewhere or hop on the Autosport Lab forum or Facebook group. The other thing is, I'm assuming that you've already installed the data logger. It's 4 wires, ground, power, 12 volt, and then CAN high, CAN low. And depending on the car, you'll have to figure out where to tap the CAN high and CAN low. On this car, it's directly on the ECU, and on the Subaru, I've tapped it at the OBD port because there's 2 pinouts with the CAN high, CAN low. All right, so once you've got it installed, the first thing we want to do is be able to read the CAN bus on the car, and you might need to kind of play around and do some configuring to get it to work. But one of the best ways to test is once you've connected to the data logger using the Autosports Lab capture software is read this configuration here real quick. Maybe there's nothing in it. Oh, there's nothing in it. Great. We want to go and grab, oops. We want to go and grab the data logger script that that Autosport Lab gives us. General purpose data logger, here we go. Grab this, and what we're going to do is paste it into the scripting section of the app, and we're going to write to it. Write complete, nothing's happening, right? So now we want to click on pull log. And if it's communicating correctly, it should spit out a bunch of CAN information, which it's not. Okay, so I'm going to uncheck that. Maybe I'll change the CAN network here to 1. Rate that. Clear this and rerun. There we go. So again, I guess not again, but I didn't say this earlier. 0 and 1 for the RX value will change the network that you're connected to, and I think on this for how I wired this up, 1 indicates network 2, and that's how I've wired it. But this is a bunch of CAN data coming from the car, right? and we need to dive into this data, and we're going to hunt for specific things. I don't like to work with the CAN data inside of the Racecapture app. It's, once I stop pulling the log here, I've got to copy all of this over, and it's kind of a pain in the butt. So once I have my script programmed into the data logger, I'll close the app, and I'll use something like Putty, and I'll connect in. Let me show you this one more time. If I launch the app, it's going to scan the different communication ports that it thinks the Racecapture is on, and once it pulls it, it connects to it, right? So same thing here with Putty. I know I'm connected on COM3, so I'm going to leave that connected as COM3. The other thing I want to do is enable data logging, because instead of having to copy and paste it, I want to use Putty's data logging feature to create a file with the CAN data inside of it. So I'm enabled all sessions, and then pick the place that I can save it and find it later. And then you're going to use serial. So go ahead and open serial on COM3. It's going to come up blank, hit enter, and if you can see here, I am now connected to the Racecapture, and it shows that this is a Pro Mark III, probably on a super old firmware, just too lazy to update it. Okay, but what we want to do is type in view log. Now that is all the CAN data coming from the car, and Putty is creating a log of this, right? So when I'm done, Control C, or is it Control C or Control Q? No, I'm just going to close it. Yeah, close the session, come over here, and I've pre-labeled like the nomenclature on how to create this, to name this file, so that's what we're looking at right there. Now I'm going to open it with OpenOffice or Excel, whatever you guys have. And boom. Okay, and I'm going to get rid of this because we don't want to look at that. And right now you can see that all the CAN data is in one column, right? So go ahead and delete this. And I can split it up by using text to columns. And I think in spreadsheets or in Excel it's delimited. And I'm going to separate it by spaces. Oops. Sorry. First thing I need to do is text to columns by semicolon. Okay, so if we look at our data here, this is the priority or channel ID, and then there's a semicolon, and then this is our data. Oops, that's a colon. Other, that's right. I think we can do spaces. Yeah. Blam. Okay, so I know this looks like a bunch of mumbo jumbo, and it kind of sort of is. Before we go any further, some of the things that we need to understand is the first value of the column is what they call CAN ID. It's like a priority. It's how the CAN network identifies priority. The lower the number, the higher the priority, and then 0 through 7, those are like the data pack. It's the data that we're hunting for, and it's the position that it's in. So to be able to tell the data logger, you know, I want to look at throttle, you have to tell it which channel ID it is, so like 587 or 582 or 1536, and then you've got to tell it in which position to look at a specific data point. And in some instances, this is 8 bytes. It might be a 1 byte data point, or it might be a 2 byte data point. It just kind of depends, and you won't know, right? You've got to kind of figure it out on your own. And then you have to understand that 1 byte can be a value from 0 to 255, right? And so when we're thinking about real life values like throttle input, you know, we can go from 0 to 100. So there has to be some type of formula there that we're using to convert 0 to 255 to 0 to 100. And so inside of the application, there is a way to like a formula conversion. So you have to enter a formula conversion so you can take this byte value and turn it into like a real world value. Right, so that is a raw CAN data dump. A word of advice, if you're looking for inputs like throttle, brake, and steering, it's easier to do it with the car in accessory mode and not running, because when the engine's running, there are way more sensors sending way more information to the car's ECU. But when the car is in accessory mode, none of that is on, and we can still get steering information, throttle information, and brake information. It might not necessarily be there, but the newer the car, the chances are, the greater the chance that that information is on the CAN bus somewhere. Okay, so now that you've seen a raw CAN data dump, and we kind of understand what like a CAN packet is, ID and the bytes, let's go ahead and do an example reverse engineering of a particular input into the car and what it might look like inside of a raw data dump. So I'm going to go ahead and close this, and let's pick something easy. Let's pick throttle, right? And I'm going to open Putty again. Now, we want to make this log as small and short as possible so we don't have to dig through a bunch of information. So what I'm going to do is enter, view log, have my foot on the throttle, not pressing it, enter, applying throttle, I'm letting go. Applying throttle, I'm letting go. Okay, close Putty. Open this again. We'll go space. Okay, so now we're looking at this data dump, and somewhere in here, we're hoping that we can find the throttle input. Now we know, because we can influence the throttle with our foot, that we should be looking at a byte value in one of these positions going from the minimum position to the maximum position. So something like 0 to 255, right? What ID it is, we really don't have any idea, but given that throttle input is pretty important or essential to the car's kind of performance and just running in general, we can assume or guess that the channel ID must be relatively low. So right, it has to be a high priority number, so it's going to be closer to 1 than, say, 1099, right? So it's going to be one of the lower values. Now there's two different ways you can do this. You can individually go through and look at all the IDs, and you can do that by creating auto filters, yes. And then what I can do is sort my IDs. Oh, look at 5. That's super low. Got no information on 5, so probably not going to be 5. 194. That's probably, let's see here. It might be one of these, you know. Oh, it doesn't look like it. It doesn't really have the pattern that we were giving as an input to the throttle. That doesn't either. The other way to do it is also to graph the channel and see if you can turn these numbers into something that's a little more visual. I think when I first did this for the Cayman, I went through every single one of these channels and looked for a number change or a pattern change in the data. And I think I did that with the WRX too. Okay. So 578 channel ID 578 byte position 5. This has a pattern that is very similar to what I inputted into the car, right? So I wasn't stepping on the throttle, 0, 0, 0, 0, 0. Applied throttle, 254, you know, max is 255, but 254 is pretty dang close, so that'd be 100% throttle. I let go of the throttle, went back to 0, right? And then applied full throttle again. So this might be it. This could potentially be it. I can kind of go down the list and keep looking, but given I've already done this, I'm just going to check and see if 578 is it. Give me a second here while I pull up an old configuration for the car. Okay, so what I've done is I've pulled up an old configuration file for the Cayman, and I'm looking at throttle position sensor here. And again, CAN ID 578, sweet, offset 1, length 1. So offset, which is going to be our byte address, 0, 1, 2, 3, 4, 5, perfect, that's correct. Length is, again, previously how I was telling you, like it could be 1 byte or 2 bytes. So length is telling the software you start at position 5 and you read just position 5 if it's length 1, or if it's length 2, then you're going to read 2 bytes and that'll read 5 and 6. So in this case, we're only looking at position 5, so length is 5. Now the next thing we need to do is scale the data with the formula to tell it that 0 is 0 throttle and that 255 or 254 is 100% throttle. And we do that with the formula here. So the formula I've used is multiply it by 100 and divide it by 255. And so right, just 0, you'd get 0, but 254 times 100 divided by 255 is almost 100%, right? So that's kind of how you do it. You know, if I want to show you how to add the channel here, you'd click Add. You can name the channel whatever you want, the units, the mix and minimax, the precision, the rate at which you want to log that channel. So the higher the rate, the quicker the Racecapture will kind of log that information. On more critical or fast changing values, you want a higher refresh rate, and on a value that isn't changing as quickly, like temperature for like coolant or oil, you can use a lower refresh rate. CAN ID, this is where you're going to enter information like 578. We're not using a sub ID or a mask. You need to enter which CAN bus you're on, and I think on think it was 2 for this one, for this car. I don't know. Offset. So that's the position again. Position 5. Length 1. Unsigned. We're not in bit mode. And I think it's little endian. I'm not 100% sure. Then you're going to enter formula. And then if you need a units conversion, you've got one that's pre-programmed in, or you can just add it to the formula. And I would save. Let me see if this is channel 1 or 2. I think it's channel 2. Yeah, channel 2. Okay. And then I'll go ahead and write that to the data logger. Go to the dashboard. Let's look at TPS. So that's at 0% right now, and if I go and step on the throttle, there we go. So that is how you do a little bit of reverse engineering or CAN engineering for the data logger. Now that is probably one of the easiest data points you can find on the car. Brake and steering, those are the next ones. The tougher stuff is going to be like coolant or oil temperature or oil pressure. If your car has the sensors to have that information provided to you, or like you know that, for example, you can plug in an access port and log that particular data point, or you can in this Cayman I have a durometric cable that I can plug in and read via Porsche's proprietary protocol that information. Then I know that the car has a sensor that is giving me data for that. So what you can do is when you are doing the reverse engineering, for example, temperature on this car, what I had to do was just read the data when it was cold. I would run a CAN log when the car was off, and then turn it on, let it idle for 10 minutes, and then read the CAN log after 10 minutes. And I knew that inside of the log somewhere there was a data point that it would have 2 different values. And then at the same time, when it was cold, I was using the durometric cable to read what the coolant temperature when it was cold, say 80 degrees Fahrenheit, and then let it idle up for 10 minutes, and then read that temperature again, and say maybe it's like 210, right? And that would enable me to create a formula, knowing that what the byte value was when it was cold versus after it had warmed up for 10 minutes. I could correlate that byte value to a real world value and then create a formula. That is sort of the trick with some of the more difficult data points that you're looking to gather. There's actually a more advanced trick that I was using on the WRX, which I will go into next because it's a little bit more complicated. But if you're just looking for throttle, brake, and steering, the way I did it here is probably going to be the easiest. And it might take some work. I did that relatively quickly because I've done it on this car. But when I first started doing it, I think for me to get throttle, brake, and steering, it took me a week, if not longer, working every night. So it takes time, and you are going to scratch your head on it. It's worth kind of. It's a fun project. It's a fun project, right? You might get frustrated, but when you finally figure it out and you have that information coming from the car, it's super satisfying. But in any case, definitely do some Google searching to see if you can help yourself out. And don't have to rework the wheel if someone already figured it out for you. And just be persistent, and I'm sure you'll figure it out. If you have any questions, don't hesitate to ask. And as always, thank you very much for watching. We'll see you at the next video. Take care.